Well, hello everyone, and welcome back to Adrian's Digital Basement. It's Wednesday, so you know what that means. It's a midweek mini mail call. When we ended the last video, I only had 2 packages, but some more have arrived, so we have plenty to get through. Let's get right to it. All right, our first package is from Soy Generous. Not sure if I'm pronouncing that right, in Rolla, Missouri. All right, so let's see what's in here. A little envelope. What do we have here? Oh, yes. Okay. What we have here are repair parts for Commodore 64 cases. These Commodore 64 repair parts were generously donated to me by Jeff Birt. Jeff has a channel that's simply called Hey Birt. I'll put a link to his channel and his video describing these things in the description below. And you may have seen other YouTubers showing off these repair parts. What Jeff has gone ahead and designed are some rear clips or clasps that you can glue onto your bread bin top covers to restore the ability for the machine to close properly. These very commonly break off. But he's also come up with these awesome little things to repair the keyboard standoffs, which also so routinely break. And he's also come up with the motherboard standoffs here, the replacements for those. And he also has the replacements for the screws, the 3 screws to hold the bread bin down. All of these parts are for repairing all those commonly broken things on the 64. He included a drill bit, which I know is for properly installing these motherboard standoffs. So that's pretty awesome. Of course, I have bread bins that need some repair, so I'm going to watch his video on the proper way to do it and give it a try myself. So I want to start on the Ziff 64. If I lift this thing out of here, this case bottom is in bad shape. The specific problems are with these little standoffs here. Now this one is okay, it's not too bad. But the one over here in the corner is completely missing. And I might not totally care about this particular C64 because this is sort of my test one. But the issue with this being missing is the motherboard sits too low in the case and it makes it hard to use the cartridge slot. Down here, this one is also broken. There's only half of it there, so screws don't stay in. This one in the middle is kind of there. It's cracked, but it does hold a screw as long as I don't tighten it too much. And then over here on this corner, there's barely anything left. A screw doesn't stay in. And it's the same up here on this corner. It's only half there, so screws don't stay in that hole either. So I was just watching Jeff's video to see how to fix this. And you need to cut these posts off. All the posts that are broken need to be removed. So I'm going to use these side cutters. I'm just going to cut these right off. These 64 cases are so brittle. It is very, very easy to crack these. Whoa, that hit me in the face. Make sure you're wearing glasses when you're doing this, or safety goggles, just something to protect it from hitting your eyes. I'm going to cover this with my hand when I cut it. Don't want it to fly up again. Try to get these cut down as close to the case bottom as you can. Now these are cut down almost all the way. You need to use some sandpaper to just try to get it as smooth as possible. All right, cool. All of these are pretty smooth. Next step is to take some alcohol and just clean up the spot on the motherboard where we've sanded, because we're going to be gluing or epoxying those little standoffs onto the case bottom here. Oh, actually, before we do that, I forgot you need to kind of take the drill bit and just make sure that little hole that's there doesn't have any plastic remnants in it. We're going to be using that to align the little standoff. Okay, now let me clean this again since I've now touched it with the drill bit in my fingers. All right, all 4 are clean and sanded, so we're ready for the next step. So in Jeff's video, he used plastic welder. Personally, my favorite epoxy is JB Weld. It's 2-part epoxy. You can find this in the auto parts store or pretty much any hardware store, at least in the US. It works amazingly well. I find it works on pretty much every surface I try it on. It works on plastics. It works on metal. It's waterproof. It's heat resistant. It's just overall a fantastic product, and it's very inexpensive. I prefer these double tubes over those syringes because I can just squeeze out just a little bit, just the amount I need, so I'm not wasting it every time I go to use it. To not create extra garbage, I'll use this packing envelope that he sent the parts in. I cut off a cotton swab. I'm going to use that to stir it up and apply it. And we're going to be using 4 of these little standoffs. So I just want to prepare them by using alcohol to clean the bottoms, just so they are completely clean before I glue them down onto here. So a little IPA on this paper towel. And this JB weld, like I said, it's 2 parts, so you just squeeze equal amounts out of the 2 materials. One of them is sort of a white color, one of them is this black color. You mix them together and you get a nice gray, sort of very strong epoxy. You just want to make sure this is completely mixed. I keep blocking the camera. I apologize for that. I really need to put the camera on the other side because I am right-handed, so I seem to always use my right hand, and when the camera sits on the right side of me, I constantly block it. But yeah, you mix this JB weld up until you just get a nice kind of dark gray color. I find that works really well. This stuff is great. I repaired a hole in my dishwasher with this, where basically one of the gears that holds the top rack on had made a hole and had pulled out. Well, I jammed a bunch of JB weld in it, and it's been like that forever, and it's still great. No leaks. I thought I was gonna have to buy a new dishwasher. All right, so I'm just gonna wipe this off so I don't have quite as much on this cotton swab. Next step is we take the drill bit, we grab one of the little standoffs, and we're gonna stick the drill bit into here. So we need to be able to stick it into the standoff and then be able to pull it out. Okay, I'm struggling with this. I'm gonna hold the drill bit. That was the trick. I can pull this on and off the drill bit. So what we do is we take this, we stick it in there, and then we make sure that we can align it on the hole. We're gonna use there's a little divot in the case already. Push that down. Okay, so that's where it's gonna go. And I'm gonna take some of this epoxy and stick it on this. And then I will put that in there. I'm gonna pull the drill bit out without moving it. Give it a little push, and it's good. Of course, I have JB weld on this drill bit, so that will ruin that, so I need to make sure I wipe that off. So that one's on there, just needs to dry, and I need to repeat the other 3 corners. And all 4 of these are now applied. I just have to wait about 24 hours for it to fully cure before I can try to screw anything into it. Jeff mentioned if any of the epoxy fills the center hole and blocks it, I can use this drill bit they included to drill through any of the extra epoxy. Okay, enough time has passed that these are sufficiently cured. I think I'm ready to test this out with an actual motherboard. First thing I'm going to do is take the drill bit that Jeff provided and just run them through these holes to make sure that they are cleaned out inside of any of that excess epoxy. So just trying with my fingers seems that I'm unable to really turn this. It's gripping onto the epoxy that's in there. So I'm going to get the drill and try to make those holes a little deeper. I'll use a cordless drill that has a good variable speed control, so I can go very slowly. I would ideally want to use a hand drill. I just need to buy one of those. I don't have one yet. All right, that should be sufficient. Here is the XIF64 motherboard that I keep in this case normally. I'm just checking out the alignment, and it seems to be pretty good. That hole looks good. That hole's the one of the existing ones looks good. That's good, 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 good. All 6 holes are in a good spot. Okay, screws. See what I got in here. Lots of 64 screws. I want to pick screws that are the short variety like this. All right, here we go. It's actually screwing into the material. So I just thought about something. If the hole doesn't go down far enough because it's filled with epoxy, then it's quite possible that I'll bottom out and then I'll accidentally rip the entire standoff off the plastic. So my solution is typically I'll stack a couple of these little paper washers up under the screw, and that way the screw pushes down the motherboard with these in place. Because I find if the screw is all the way in there, when it starts to be hard to turn, the motherboard is still somewhat loose. So I'll screw on about 3 of these little paper washers, and that should add just enough to the screw so that it can go in all the way. There we go, it's bottomed out, and the motherboard is tight. Excellent. Let's try the next hole right here. I got 3 of those little paper washers on as well. There we go, it's on there tight. So I ended up using 3 paper washers on each of the 4 corners where I had put Jeff's standoffs, like this, and here, and right here. And Jeff, thank you so much. That did the trick. This motherboard is in there completely solid, no more flopping around. It used to flop around when I unplugged the keyboard or if I did any kind of movement on this side of the case. And since the standoff was completely missing on this side, when I put a cartridge in, it would actually rub against the bottom of the case here. Let's see if this works better now. Well, at least my Easy Flash 3 still does rub against the bottom of the case to some extent, although it doesn't do it as badly as it was doing before. But I wonder if that again is a side effect of the fact that without the RF shield on the bottom of the motherboard, it sits slightly lower in the case. So I might need to add washers under the motherboard on each of the 3 screws on this side just to raise it up ever so slightly. And then next up to try to repair is this Rev A machine. Now, unfortunately, it's not the gold label. I don't know why. This is a mishmash. It's got the original orange keys. It's filthy. I haven't really cleaned it. But if I take this off, inside we have this Rev A motherboard, which I'm happy to say works. I repaired it in one of my repairathon videos. But taking a look at this top cover, this clasp right here is broken off. I'm checking to see if anything is broken on the keyboard, and actually no, on this one, everything is looking okay. The keyboard is attached properly. I don't have it screwed in very tightly, so keyboard is a bit loose, but that's what I do. If I'm not sure this keyboard's gonna stay in here, I don't tighten these down because you risk breaking those things. But this here is definitely a problem. So Jeff sent me 2 sets of these clasps. Now he has a lot more on his website, and you have to basically order the ones that are appropriate for your particular case you're trying to repair. One set are 2A case clasps, which are those 3. And then he has another set here, which are 1B, 1 Baker. Now I know right away that this case is a 1B case, and that's because there are 3 equal size clasps here. So watching Jeff's video, he said the first step is you need to trim down anything that's sticking up above this edge. Now on mine, you can see it broke off completely flush. There's nothing sticking up whatsoever, but it's possible when it snaps off that it leaves some amount that's sticking above. So you have to use the side cutters or a knife to cut it down flat, just like this. So really my next step is to use some alcohol just to clean this off, just to prepare the surface. And the same for this 1B replacement clasp. These are 3D printed. Those other little standoffs for the motherboard were not 3D printed. Those were actually machined, CNC machined. And the way this is going to work is there's a little step on the top of this, and you stick this on here and you push it down so it's completely flush. So I just need to epoxy that on. Okay, luckily JB Weld sets up pretty slowly, so I still have some of the epoxy, which I can smear onto here. Make sure I have a good amount on there so it's nice and strong. He said you should put some along the top edge as well. All right, there we go. I'm just gonna stick that on there like that. JB Weld is quite tacky, so it sticks pretty well, but I just wanna line that up. Make sure it's centered as good as possible. And I have one of these clamps here. I'm gonna use this to just hold this together. And now we wait 24 hours for this to dry. Let's take this clamp off here and take a look, see if this is actually on there well. Yeah, this appears to be held on there. It's definitely not budging whatsoever. Now, Jeff in his video indicated it was probably a good idea to sort of round the corners of this a little bit, just to help it engage with the case a little bit. So I'll go ahead and do this now. I think I should have done this before I glued this on, to be honest. If you want to avoid some of the popping you hear when you put the case on and take it off, you could probably go ahead and round these off. All of them, even the stock ones, could benefit from this. He says it's the way it interfaces to the bottom of the case that causes that. So just rounding it off a little bit apparently goes a long way to helping avoid that popping noise. This is the case bottom, and I just realized now that this also needs standoffs. All the screws are in this case, and yet it lifts straight out of the bottom. So yeah, oh, it's pretty rough. Most of those standoffs are bad. I think I'll have to get the JB Weld out and fix this one as well. But really, let's test out how well this new clasp works, putting this top on. Well, unfortunately, JB Weld might not be the right material for attaching these, because take a look. That just came straight off, and it left a nice coating of JB Weld on here. Oh boy. Okay, well, so really it's probably best to follow Jeff's advice and use plastic weld. So a bunch of time has passed, and I used some glue to reapply this. Now, the JB Weld is under there, so I have no idea how strong this is going to be. Looking at this down this way onto the case, I see that I have it at an angle. I can't believe how much of a bad job I'm doing applying these. I'm really sorry about this. Well, let's see if this goes on. Whoops, the motherboard is falling out. Oh, I'm hearing all sorts of cracking noises. I think I've basically ruined this thing. There's no way this is going to be held on anymore. Let's just take that motherboard out. Okay, well, what's amazing is this didn't break off. I just heard a lot of that horrible cracking noise. So I'm not quite sure why. Let's try it without the motherboard in there. Oh, you know what? Actually, this is holding together okay. So in the end, this actually did work, even though the JB Weld was a fail the first time around. Crazy Glue, which is cyanoacrylate glue, worked pretty good for me the second time around. So thanks very much, Jeff, for sending these in. I really recommend if you buy some from him that you follow his instructions on how to put them in your machine. Don't follow my terrible instructions. Anytime I deal with glue, I always mess something up. So ignore everything I said other than the fact that these do work and they work well. I need to go through all my bread bins now and look for any that have busted parts so I can repair them. I'll put a link to Jeff's site so you can buy these parts for yourself in the description below. He also makes repair parts for some Amiga machines, so if you have broken bits on those cases, check out his website. All right, my next package is from Christopher in Bridgend, UK. Hello to all my UK viewers. This is a large flat package. I actually know exactly what this is because Christopher reached out to me and wondered if I would like some of these. Oh no, look, it's that horrible paper shredded. I mean, it's good for the environment, it's recycled, but don't cut that open the way I just did. Not just let out a bunch of fluff. Let's try that again on this end, which has the tape that's sealing it closed. Okay, everyone, check this out. Look at this. What we have here is a sight to behold. It's actually 2 replacement Commodore 64 motherboards. Both of these are long boards. This is the earlier 25407, so this is not the Rev A, very first 64s. This is one of the more common breadboard versions, in my opinion. This one here was the later revision that has the 8701 clock chip, so they simplified this area around the VIC. These boards are absolutely beautiful. I am blown away with how nice these look. So I've turned off one of my overhead lights to try to eliminate some of the glare on this. It's still glary if I tilt it that way, but if I hold it like this, it looks much better. Let's take a closer look at this 25407 board. So down here in the corner, it says version 1.1, reverse engineered by Rob Taylor, January 2020. And right off the bat, I'm loving the fact that the silk screens have the part numbers written inside of them. If you saw my last mini mail call where I ranted about PCBs that don't have that, this is a nice, refreshing change. Although I would have loved to have had the values of these components, these passives, also written in here. So you knew that R42 was whatever this is, 10K resistor, instead of having to go look it up. But looking around the board, it says stuff like CIA 6526, keyboard connector, user port, cassette port, serial and audio video. And then under the RF modulator here, it says hashtag SixtyClone at Peepo UK. And I get down here, so it's the assembly number 25407. That's the part number I always refer to. But the original one also had an artwork number that sort of varies slightly from one board revision to another. 251-137 Rev C in this case. But SixtyClone and MDK 10HB, whatever that stands for, and obviously 1983, I think was the year the Commodore had printed on the original as well. This board overall looks incredible. I'm at a loss for word on how nice this is. It has a very modern construction style where the vias, of course, are tiny and are also covered in solder mask. Now, I have soldered a lot of bodge wires onto vias before on regular 64s. They're giant and big on those ones. But on this board, they're covered in solder mask, so it's going to be hard if you ever need to bodge a wire onto it. Although, why would you with this particular board? All of the exposed copper on this board is coated in this nice gold covering. I assume it's gold or a gold alloy of type. It's really nice looking. Look at it. Look at how beautiful it looks. It's shiny and has such a nice luster to it. There's a nice large chunk of it here where the regulars go. This thing just looks nice. The back of the board looks pretty much as it should. Has the assembly number printed on the back again. And there's a nice message on the back here with some thanks, plus all the support and kind words from friends on Discord and Twitter. You're not going to find that written on the back of a real 64. This board is completely stock from my understanding, with no modifications or changes whatsoever from the actual 25407 version of this board. So it's completely interchangeable with all parts. If you desoldered everything off of the 25407, it would go right onto this board and it would work perfectly. And moving on to this other PCB, this is the later 25466. It's in a beautiful blue color. I just love how it looks. Again, this is a bone stock replacement for the original. There's really no changes whatsoever. It has the same 2 separate 64x4 RAM chips. Down the corner here, it's reverse engineered by Rob Taylor again, Peepo, version 1.2, also January 2020. Has the same beautiful luster on all of this exposed copper here. Notice here it says SixtyClone 1986, and that's because, of course, like I said, this was the last revision of the longboard that was out there. They moved to the shortboard very soon after this came out, and the back of the board looks sexy and beautiful, just like the other one, except the beautiful blue color. We have some special thanks here as well, the same message that was on the other one. And here we have these markings on the back as well. So a huge thank you to Rob Taylor for sending me these two boards. Unfortunately, I can't turn one of these into a working 64, not on the mail call. This is going to be a long project to build one of these up, especially because there's a good number of components on here that you can't buy anymore. So I will have to source those off of another 64. And I don't actually have a parts motherboard for either of these two revisions. All of the versions of these two boards I have work properly. But this board here is actually the same exact revision as what's in the field Found 64. And that board does have quite a bit of corrosion on it. So perhaps when that board finally has issues because the traces under the solder mask have corroded, I can take those parts off and build them up on this board and have a beautiful brand new replacement for going inside that old case. So look for me doing a project with these boards at some point in the future. Next up, we have a package from James in Pawling, New York. Let's cut this open on the end. What do we have in here? It says, just a week or so ago, I found this while cleaning out some old boxes. I don't remember if I bought this at some closeout bin at a software, etc., which the price tag shows, or at some tag sale flea market. Would seem a bit too clean for condition for a flea market find, though. Should be interesting to see how repairing C64s have changed, sometimes out of necessity now due to age and parts availability. It also looks into the theory of how the components work. James said he sold off all of his vintage collection over time, but somehow this book survived. So he found this and he sent it over to me. Troubleshooting and repairing your Commodore 64. This is going to be fascinating to read. And just as he said, there's the price tag, $16.99 from Software, etc. That company is long gone here in the United States, but that company was a pretty big chain that sold software and games and books and everything you needed for your computers. And unfortunately, like all the other stores of its type, they're just gone. I love this picture here. So this is one of the earlier keyboards with the kind of orange F keys. Look at this ancient multimeter. And then we have a 25407 motherboard, and I wonder if they were doing an RF modulator mod, which is why they took the cover off there. I somehow doubt it. All right, looking at the back, an invaluable and money-saving tool for every C64 owner, as well as unbeatable technical reference for service professionals. If you own a 64, this book is probably the most important add-on you'll ever purchase. Those are big words that I somehow don't think is necessarily the case. I really think that something like a better monitor is the best add-on you can get for your 64, or at this point, a replacement power supply that won't kill your computer? It does say right here, the simple chip changing instructions alone will enable you to cure at least 50% of problems that cause micro breakdowns. Not major breakdowns, micro breakdowns. Down here, tried and true service procedures for pinpointing trouble spots, electronic and mechanical techniques for chip replacement. I'll be very curious what it talks about there, especially if it's soldered down. 21 test point charts showing exact pinouts and the name of each pin, arrows indicating direction of signal flow and readings you should receive using a logic probe or VOM. Volts-o-meter. Okay, there's really something to be said about having a book that shows you the pinouts of these chips, because unless you had the actual service manual, it's not like you had the internet back then you could go look stuff up on like we can now. So this is handy, to be honest. If I had to try to repair these back in the day and I didn't have the official Commodore manual, which would probably cost a fortune, this could be actually quite useful. They give you a schematic for the C64 as well, along with part numbers, an essential tool for more difficult repairs. This book was put out by Tab Books out of Blue Ridge Summit, Pennsylvania, and you could send in for a free Tab catalog describing 1,200 current books that they have. Ooh. This book originally did cost $16.95, which matches that price tag that was on the front of the book, and of course, price is higher in Canada. People in Canada, you're always screwed. It just sucks. Inside the cover here, we see it's the first edition, fourth printing, printed in the USA in 1985 by Tab Books. And in case you're looking for a copy of this yourself, the paperback, which is what I have here, is ISBN 0-8306-1889-9. So I'm perusing the book here, and it starts off with a pretty basic description of what various problems are, and that's actually kind of useful if you really are starting from scratch at troubleshooting these machines. And it has a simple diagram here showing the various chips on the 25407 board. It's interesting that it's basically talking about the 25407, which was the most common 64 out at the time. But of course, the earlier Rev A boards did exist in the US, and they had a little bit of a different layout than this. It's talking about how the data bus is interconnected with everything. This section here is talking about the 74LS257 multiplexers that handle the RAM. We're still in chapter 1, and this is a little troubleshooting section. Disk won't work. CIA number 2, replace chip. Printer stops, 1 or 2, replace chip. Keyboard won't work. Keyboard or CIA 1. Modem, video, SID, VIC. Yeah, I mean, it's pretty basic. You know, if these chips are socketed on your machine, it's definitely something you can just try swapping out. Of course, this implies that it's trivial to get these chips to swap out. So this section of the book is talking about disassembly, and I take issue with something it's already talking about. It says there are 32 chips on the main board of various sizes. Of the 32, 8 of the largest are plugged into chip sockets. Well, that is definitely not always the case. I've had boards where basically nothing was in sockets except for the VIC-2 chip. I've never seen a VIC-2 soldered. That is always in a socket. But every other chip on this 25407 was soldered in. So I'm surprised this isn't saying that sometimes they're soldered and sometimes they're in sockets, because I've certainly seen every single permutation, but they seem to indicate here that all the large chips are in sockets. It does say here that carelessness will result in induced troubles. That's very true. Like if you scratch a trace or rip something out, I mean, that's going to make your computer worse, right? You might have a simple to fix fault, and your attempted repair actually caused more damage than the computer actually had. Disassembly as a cure. Sometimes just taking it apart actually fixes it. I suppose that might be the case, a chip in a socket, but how much of a problem really was that when the machine was like a year old? Seems like a failure at that point was most likely going to be actually caused by a bad chip. But it's talking about solder blobs and things like that, so that's possible that those could screw up the motherboard during assembly. Okay, check out this section. The ground plane short. A common short happens when a chip leg pushes in and punctures the insulation between the printed circuit board and the ground plane. You know what the ground plane they're talking about is? It's the RF shield. So here's the PCB. This is the cardboard that's in between the PCB and the RF shield. And they're showing that it's possible that a leg wasn't cut properly and can actually puncture and short out on the RF shield. More reasons why RF shields are bad. I've never actually seen this problem, but I guess it's technically possible. And maybe any of the machines that had this fault early on were fixed. So, you know, I don't get, by the time they get to me, this is not an issue, but that's pretty amusing. If the RF shield weren't there, you wouldn't have that problem. Oh boy. Well, I'm reading the section on desoldering, and it's pretty bad. It goes and talks about something that's weird. It talks about using a lamp cord clip lead. I don't even know what a lamp cord clip lead is. To heat sink between the connection to be desoldered and the chip. What? I'm not even sure what it means. But really, it's talking about the technique for desoldering is to slowly apply heat to the PCB, jiggle the pin with a solder pick, and wipe the connection. Keep doing that patiently until that pin is free. It could take a number of picks and wipes. Most of the solder in the printed circuit board hole will be removed. Once the pin is free, go on to the next connection. Pin after pin is freed. Keep working till each pin is free, then lift the chip off the board. That is not descriptive enough, and that does not tell you what you need to do to desolder a chip. And it says here, if the chip is defective, you just want to get it out, you can use less care. You apply the heat and pry faster. After a while, the chip will pop out. What? Pry? It says, just be careful not to disturb the board and the nearby components. This book says nothing at all about the danger of lifting traces. Just because these boards I'm working on now are 30, 35 years old, that doesn't mean it wasn't easy to lift a trace back then, especially if you're using reckless techniques like described in this book. This section is talking about resoldering. This section is funny. Often a particular chip is a victim of manufacturer design mistake. The chip will, over the life of the computer, fail time and time again. What? That doesn't make any sense. Why would the guy write that? But he's basically advising you that if you do remove a chip from the board and you're successful at not destroying the board, install a socket before you put the new chip back in. The book has some good sections here on theory of operation of the various large MOS chips that are on the board, CPU and the CIAs and the SID chip and stuff like that. So this is a decent section for that. If The book goes into pretty advanced detail on all the various chips in the 64, and we're looking at the pinout of the VIC-2 chip. He shows you what each of the pins should be doing when using a logic probe, like pulsing, or just high, or low. So that could be potentially useful, but when we look at the section on testing, he literally just says, well, hopefully you understand the theory of operation of the VIC-2, and then check with a logic probe to compare to this diagram here and see if it makes sense. Otherwise, you might have to just switch the chip. But throughout the book, there are sections on trying to isolate what the specific problem might be, and then what type of signals you might see if you use your multimeter or your logic probe on various test points. Here are the pinouts and the signals you should be seeing when you're looking at the CIA chips. And he does also go into some programs, some simple basic programs with peeks and pokes, where you can try to manipulate some of the values of these lines to try to isolate problems. Of course, that implies your 64 is working for the most part, or you can actually type in commands. And what I haven't seen a lot of so far is troubleshooting black screens on the 64. Here we are in the SID section of the book, and yeah, he gives you some poke commands to try to make it generate some sound so you can try to figure out if there's an issue with your SID chip, which of course now we know is a super common failure point, but probably not in 1985 when this book was written. When he talks about testing, he doesn't really do anything else except tell you how to poke some sounds into the SID to make it make noise. Doesn't really talk about any other troubleshooting steps. The last section of the book talks about the power supply, and of course back then when this book was out, we didn't have the problem of these power supplies killing the machines. So it does talk about how to test the voltages and what the signals should look like, plus a little circuit diagram here. So that's pretty nice. Overall, I feel that this book is not particularly useful in this day and age because a lot of the failure modes that we have commonly with 64s are not discussed even in the slightest in this book. I would be really curious to hear from a technician who worked on 64s back in the early 80s when these machines were common and plentiful. What were the common faults back then? Was it the same stuff we see today, like PLA chips and SIDs going bad and RAM chips going bad, keeping the computer from working, stuff like that? I'll be very curious because I have a feeling it's probably not the same as these chips age and they fail in specific ways that we know about. It's probably not the same as it was back then. Oh, and the back of the book does have the schematics, the full schematics for the entire computer, the 25407 at least. So that's pretty helpful. Like I said, if you didn't have the service manual, this would be a great resource to you if you were trying to troubleshoot your machine to figure out what was wrong. And really, my final observation about this book is, like I mentioned, it seems to only deal with the 25407 board, and it seems to only deal with the one machine that this man had. It felt like Art, who wrote this book, didn't talk to technicians about how this machine fails, like what was a common failure mode back then. It felt like he studied the design of this machine very thoroughly so he could turn that into this book. But nowhere in this book does it seem to show a chart where it's like, if you're getting this kind of garbage on screen, it's probably this chip or these chips that you should look for. It doesn't seem to have any of that. It's really heavy on theory and it's really light on actual suggestions on how to fix things. So if you're very interested in the 64 and you want to know from a theory perspective how all the components in the 64 work, this book might be useful to you actually, because it's pretty nice to have it all in one place. For a simple troubleshooting guide, this book is definitely not that. So thank you very much, James, for sending this to me. Even though I don't think it's very useful, I still think it's neat to have, and it will go on my bookshelf with my other 64 books. Well, that's going to be it for this midweek mini mail call. If you like this video, you know what to do. Hit that thumbs up button. If you didn't, you know what to do as well. Hit that thumbs down button. Put your comments and your suggestions in the comment section below. You can subscribe for more videos. There'll be lots more in the future. And if you do want to donate to me, there is an address you can send it to down at the bottom of the description in this video and all my videos actually. Plus, if you want to email me, you go to my channel about page on your computer on my ad, and you can email me from there. Thank you very much for watching. Stay safe, stay healthy, and I'll see you next time. Goodbye.